If you're writing the 2026 NECO chemistry practical, let's solve this question. It says A is 0.0486 mole per dm cube of a dibasic acid, while B is 4 gram per dm cube of sodium hydroxide. Titrate A against 25 cm cube of B using methyl orange as indicator. Repeat the titration 3 more times and record your results in the table below. Calculate the average volume of A used. B. From your results and the information provided, calculate the number of moles of acid in the average titer. Next, calculate the number of moles of base in the volume of B pipetted. III, calculate the mole ratio of acid to base. IV suggests what the acid could be. The theoretical titer value for 2026 NECO is 25.70 cm cube. Please use what you have in your center. Do not use this unless they are the same. Next, calculate the number of moles of acid in the average titer. The formula we're going to use is Na is equal to CV all over 1000. C here represents the molar concentration of the acid, while V represents your average titer. So to substitute, we have 0.0486 times 25.70 all over 1000, 0.00125 mole. Next, DII. We calculate the number of moles of base in the volume of B pipetted. To do that, we use the same formula. NB is equal to CV all over 1000. But in this case, we do not know our molar concentration of base yet. So in that case, we need to calculate the molar concentration of base. And to do that, we use the formula. CB is equal to mass concentration all over molar mass. But molar mass equal to 23 plus 16 plus 1. That will give us 40 gram per mole. Next is to substitute. So our CB becomes, remember that our mass concentration is 4. So we have 4 all over 40, which will give us 0.100 mole per dm cube. This is the value of our C. So let's substitute. Our NB is equal to 0.1 times 25. 25, of course, is the volume of pipette. So we have all over 1000. And that will give us 0.00250 mole. The next step is to calculate the mole ratio of acid to base. The number of mole of acid is 0.00125, while that of base is 0.0025. The next thing is to divide both sides by the smallest. When we do that, we have 1:2. The next question is to suggest what the acid could be. Since the acid reacted with the base in a ratio of 1:2, the common dibasic acid that can react in this ratio is H2SO4, as seen in this equation. H2SO4 plus NaOH, giving us sodium sulfate and water. Balancing this, we have 2 here and 2 here. And this is reacting in a ratio of 1:2. So the common dibasic acid is H2SO4. I hope this helps. Bye for now.